Okay, the following three examples should be fairly quick. We're asked to give rectangular coordinates for the given points, and so the neat thing is that they gave us polar coordinates. So we've got 2 and we've got 270 degrees. This is our r and this is our theta. And so that's really nice because to give the rectangular coordinates is a piece of cake now, because all we have to do is pay attention to what the x value is and what the y value is, and that's fairly straightforward and simple. So let's see here. Number 5, we're going to say, well, let me put number 5 over here. This right here is looking for x and y. So we're going to write our answer right here. And we're going to say x equals r cosine of theta and y equal r sine of theta. And we're going to fill in what we know. 2 cosine of 270 degrees and 2 sine of 270 degrees. Okay, and for lack of, well, okay, so now let's just go ahead and jump over to the unit circle and take a look and see what that looks like. The cosine is right here, 0, and the sine is -1 at 270 degrees. So we're going to have 2 times 0, and over here we're going to have 2 times -1. So this one's going to be 0, and this one's going to be -2. And so the rectangular coordinates for these polar coordinates, 270 degrees, is going to be 0, -2. So that's the answer for the very first problem. Okay, so go ahead and pause if you need to, but I'm going to clear the screen. Okay, so here is our next example. We're going to have -10 as our r value and 225 as our theta. Again, we're going to follow the convention of this formula here to go from from polar to rectangular form. And we're going to say x equals -10 cosine of 225, and y will equal -10 sine of 225. Okay, so then all we have to do now is jump over to the unit circle and figure out those cosine and sine values, which are right over here. The cosine and sine, coincidentally at 225 degrees, are identical, the negative square root of 2 over 2 for both. So let's go ahead and take a look back at our problem. And we're going to get -10 times a negative square root of 2 over 2, and a -10 times a negative square root of 2 over 2. So that is going to look exactly the same. We're going to have a negative and a negative, positive 5, because 10 divided by 2 is 5, 5 square root of 2, and 5 square root of 2. So we're going to write here, and let me make this a little bit smaller, our answer of 5 square root of 2 and 5 square root of 2. So there we go. Another example done, where we're going again from polar to rectangular coordinates. All right, and let's go ahead. I'm going to pause it one last time and work out one more example here of this variety. Okay, and now a look at our last example of polar coordinates going into rectangular coordinates. Okay, so we're going to transform that. All right, and it's very simple. All right, we're going to take a look at this right here, number 7, which says 8 and 225 degrees. Okay, so let me see here. What do we want to do? We're going to say this is r and this is theta. X will be, again, r cosine theta, y equal r sine theta. So we're going to fill that in again. 8 cosine of 225 and 8 sine of 225. Okay, looks something like that. All right, now all we have to do is figure out what that is on the circle. So 225 degrees, again, that one right there happens to be that both are exactly the same for the cosine and the sine. So that works out very nicely for us. Okay, so we're going to say then this is 8 times negative square root of 2 over 2 and 8 times negative square root of 2 over 2. So this is going to be negative 4 square root of 2 and a negative 4 square root of 2. So again, another real simple example. Coincidence, I guess, that both of these were the same degree measure, but that's not a big deal. We're just looking at more examples for more practice. So this was just a little bit on how to go from polar form to, or polar coordinates I should say, to rectangular coordinates. So if this video was helpful, be sure to like and subscribe.